Continuing on with my look at the Deposition Sound FDMGeo 3D printed speaker kit, I'm going to do a little audio analysis today just to put some numbers behind what I'm hearing. They are very nice sounding speakers. They've got nice bass extension, a lot of clarity on top. So I'm going to do some measurements. Now, these measurements were taken in my garage. There's, a chest freezer in there. So there is some background noise. This is certainly not as good as measurements taken in an anechoic chamber, which you would have if you were an audio manufacturer. I am using my Mark of the Unicorn, an Ultralight Mark V audio interface, which is known for being very clean on its input and output circuitry. I'm also using a prototype of a measurement microphone that I worked on ages ago, back when I was a professional audio engineer. And I'm using an off-the-shelf amplifier that we picked up just to be able to power these in the shop. It's a decent sounding little unit, but I really am not going to be able to go and do full-on measurements of its performance because I don't have a resistive load to be able to test it. So with all that said, I'm going to be using the Audio Tools software suite of audio analysis. So let's take a look at what's going on with these. The first test we're going to do is to take a look at the overall frequency response from the speaker. To do that, I'm going to use the Fast Fourier Transform, or FFT. I'm going to start off with no smoothing, and we're just going to use some pink noise. Now I will start smoothing that down. There is a third octave. If we look at the octave, we've got a little bit of a room node, is my assumption, happening here between 39 and 49, so between 40 and 50. Maybe a little bit of a bass exaggeration here at 100 hertz. This is looking like there's a little bit of mid-range voicing, and then you can see there is a high frequency bump here. So these are going to sound a little hyped in the presence range that's above 8K, so that's going to really catch sibilance in speech as well as things like cymbals. It's not overly exaggerated. It's certainly just a little bit of a voicing. So let's take a look at the transfer function. So let me give you a quick explanation of the test that I just did and the test that I'm about to do. And I'm going to try not to get too far into the weeds because I really, really love audio analysis. The last test that I just did, the FFT, is a single channel test. So there is a microphone in front of the speaker. It's picking up what that speaker is putting out and displaying it on the graph that we just looked at. It's also picking up all kinds of stuff that's happening in the room. There could be reflections, there could be things happening that are either boosting signals or causing phase cancellation that actually will lower some frequencies. We have no idea of what's happening with that because all the microphone knows is what it's picking up in the room right now. The test that I'm about to do, the transfer function, is a 2-channel test. So one part of that is the source side. So I'm looking at the signal that I'm sending to the speaker. The other is the response, which is the microphone that is picking up the sound coming from the speaker. And what the transfer function does is it aligns those two signals in time and then compares them. So we know what's going to the system and we know what we're getting back from the system. So by comparing those two signals, we can get a much more accurate picture of what's going on with the system. So with that said, let's do a transfer function. Now, before I run that, I'm going to reset my delay. And that has the delay at 2 foot 8 inches, which seems about right. Now, again, I'm seeing this hump here. There's a little low frequency thing happening. And there's that dip. And we've got that hump there, but we can see the coherence trace is really good. There's a little something happening up around here that I'm not 100% sure what is going on there, but the coherence overall is still high. So this looks like a reasonably accurate system. So that's a quick look at the performance of the FDMGeos. They are really nice sounding speakers. I would recommend that if you're interested in 3D printing your own speakers, being able to do whatever kind of colorways you want, and ultimately wind up with some really nice bookshelf speakers, they are a great option. So thanks for watching, and we'll have more project videos coming for you soon.